Good morning, Mr. Palmer. How are you, sir?
Not bad, John. You let the music go longer, even. I like
I
that.
did, and you know what it was? I'm looking at my soundboard, and I'm like, "There's a way I can do it that actually." And other podcasts that I listen to do this. I need to figure out how to do it where I can fade it for like a minute, where it's still playing very softly in the background. So maybe for a future episode, I'll figure that out. I
I don't
swear
know, a
I'm getting
minute.
smarter.
Don't.
Whatever. It's just a little background music, a little mood music.
Well, then they're going to accuse us of being radio DJs, and that's not cool.
Well, I mean, we don't. Well, yeah. Anyways, so so how are you, sir? We're back for another episode, and I like that, back for another. We're segued, right? It's back to school time.
Oh, man,
It's
you
like the
went
worst.
fast
Those are
today.
like the worst. I think those are the worst words in the English language. Back to
Well,
school.
it depends. So I found out. All right, Justin, if you're listening, I'm sorry. I found out. I found out when I was an adult that my mom and my aunts that lived near me, within a couple of miles, turns out every day, every year on the first day back to school, they would all get together for a celebratory lunch to celebrate the end of summer and the beginning of their time. So I guess it really depends. There we go, Sam. It depends on whether or not back to school is good for you or bad for you.
That's true, but I still
So
think it sucks. but it's torture, man. It's summer's great, but yeah. So back to school for those of us in the wireless and networking profession means a lot of different things. And so we figured it would be a good time to have a nice special guest on to talk about Wi-Fi in
is he
schools.
is he that special? I mean, really?
He's
Not.
joining us. He's up early. He's joining us. Of course, he's special.
Yeah, we got Ryan McCaigue here. He's what are you, Ryan? Why don't you go ahead and introduce yourself to everybody?
Thanks a lot. Good
I've
morning.
obviously declared you not special. So
Yeah, just the average guy. See,
Might be the record for how fast we got off rails.
so I'm Ryan, and I'm an SE. I cover Arizona, and New Mexico, and Utah. I've been with Ruckus about, I'm coming up on 10 years. It's going to be my 10-year anniversary here pretty soon.
nice. And so
That deserves some applause.
as part of your SE duties for 3 different states, what's some of your bigger customers, the ones that you kind of work with? I mean, is it school districts or
Yeah, I've got actually I have two territory account managers that I cover, and we have a mix. So for the first many years that I started doing design work here and working, it was a lot of school district work. So school districts across the state were our biggest customers, and E-rate is a big deal for us to be able to go out and do appropriate design and work with school districts to provide the connectivity that they need. Over the last couple of years, what's really come up for me is the multi-tenant housing market. So I do a lot of support for MDU service providers. I've got a couple of very large ones in my patch that I work with, and so that's a growing vertical that's in my space. But education is still my biggest vertical in these 3 states. So we have large school districts deploying hundreds and hundreds, if not thousands, of access points across the state.
and I happen to know because I do my research as a good podcast host, unlike John, that you actually came from a higher ed background, correct?
Oh yeah, that's yeah, good point. Yeah,
Ah,
I call myself a recovering academic. So I was actually a dean for network and communication management for a major university that had 21 campuses. I rolled out their NetCom program, and we did online and in-person lab experience. We did everything from BICSI compliance testing to certification on switching and routing and telecommunications phone. So basically everything in that space, we trained technicians, engineers that would go out and deploy and do networking. So I did 16 years in higher ed, and the students kept coming back telling me they were making more money than me. So I was like, I think I'm going to go do something else.
I was going to say, I've heard that a lot. I've interviewed a few times to my bosses who might be listening, nothing recent, higher ed. And I've talked to a couple of people that work there now, and they're always kind of floored by the salaries they can get out of higher ed, but they also were very, very big on the perks. I know, I want to say 4 or 5 years ago, I interviewed at a couple different colleges in the area, and I'm in New York. And for me, the one big appeal was free tuition. As a parent of triplets, I was like, sign me up. That's huge. But
yeah.
But now,
yeah, for me, it was the lifestyle. I love the lifestyle was wonderful, right? So, you get that little summer break, and there was just something about it that didn't have the pace of life that I have now. That's for sure.
So, it's funny. You talk about the summer break. And I know one of the things that I always look for on social media when we get to this time of year, the end of the summer break, is I always see the post come up. And I guess now it's a post, not a tweet. I don't know. That's a complaint for a different day. But I always see the pictures come up. I mean, it's like, oh, you can see the students coming back in, because you'll see this flat line of clients. And then all of a sudden, like, those clients start to climb as the administration kind of comes back in, and then some of the early students, and then the main push, and you can see those spikes go up. And it's always interesting to me, because you can spend the entire summer working on your network, and then you have like this 1 week period where it goes from absolutely dead nothing to this massive load. And it's always like, how do you, when we talk about education and this demand for, making sure that it works right on the first day, what are some tips and tricks that you found over the years of working not only in your previous position, but also, what you do today, what you've been doing? What are some of the things that you found that is like, hey, these are some essential things that we always check when we're getting ready for our back to school, as will the network support, this influx, and as everybody returns to the classroom?
Yeah, that's great. And it's really apropos, because yesterday I had a couple of panic calls from some schools right off the bat, right? Yesterday was the first day here as well. And so these spikes in traffic, a lot of times there are hidden things in the network that cause issues with connectivity, and they're so highly dependent on Wi-Fi to work. You can't interrupt the learning process, and teachers will immediately go to plan B if anything fails in the technology space. And nowadays, with all the online testing and other things, it's mission critical. And so for us, I think the first part of essential operational stuff is to do good design and good Wi-Fi engineering, and to understand the properties around Wi-Fi. My favorite statement is always to say less is more in Wi-Fi. And what I mean by that is you've got to find a balance. I would love to sell you a lot of access points. That retires quota, right?
Right.
So it's great when I can just, hey, put more APs in. But in reality, more is not better. And more APs creates some problems in the network. And I think many schools have been tempted to take what I call the easy button. Let's just put an AP in every classroom. I've been to schools where I saw as many as 4 access points in a classroom, and 2 in the one next door. And I said, well, why do you have so many APs? Well, this is the computer lab. And I was like, oh my God. No, you guys don't understand that device has got limitations, particularly around channels and bandwidth. It's turn taking, right? It's a CSMA, not collision avoidance, or collision avoidance, not collision detection. So the idea that it has to ask for time to be able to transmit. And if it's taken turns with all these other access points and they're on overlapping channels, that turn taking is latency and poor performance. So good RF design is the first thing, to make sure that you're finding a balance.
So,
And okay, you go, John.
I was going to say I had to jump in on this one because this is I've heard for years. You look at Twitter and X, whatever, and YouTube, and you watch all these school design people, and I've always told it was just one AP per classroom. You're saying it's not that easy?
It's not that easy, and actually you're not doing yourselves any favors, right? So I kind of liken it to the noisy room, right? The three of us are taking turns talking right now, right? And there's not a lot of contention for the airtime. But if we were in a really loud room, a conference area with hundreds of people talking at the same time, it'd be very hard for us to hear each other and to communicate effectively. And so as we add more access points into an environment, even if we have to turn the power down, and there's some trade-offs for that, those signals carry. And whenever there's APs on the same channel, they're contending to use that channel. They have to take turns. So by appropriately spacing the access points, using the attenuation of the walls of the environment, we can control the spread of that signal in a way that we try to minimize as much as possible that co-channel interference, the idea that two APs on the same channel are going to be taking turns in that space. So getting them appropriately spaced is key. Depending on the structure, I may do one AP in every second or maybe even every third classroom. Now, the caveat being that your AP has to be engineered to handle 30, 60, 90, 120 concurrent user devices. And I think ours are. They routinely handle that and no problem. So I think that it's ultimately a question of doing good RF design up front, understanding the properties of the building and placing the APs in appropriate distances and giving them as much headroom, I'd say signal to noise ratio as possible, so you get high throughput communication. I want devices on and off as quickly as possible with as high a bandwidth as I can get.
Yeah, and I think the thing that I find interesting, and you've done extensive work in educational spaces. I've only done a couple projects, but the thing that's probably most interesting when you mentioned design, and you hit it, and I like how you said it, it wasn't 30, 60, 90, 120 users. It was user devices, because I think that's one of the areas that really has been exploding. You used to go into a conference room or a auditorium and you'd see a couple APs because, you're going to have 100 students in there. Nowadays, 100 students might have 400 devices that are connecting to Wi-Fi. That part's really, I think, been hard for some people to kind of get their heads wrapped around, that it's, you can have a 20 user classroom and your needs are like the class size is not growing. It's the device count that's going up. For
sure. Well, and then, there's interesting environments in schools too, like, I don't know, they call it we used to call it the cafeteria. Now it's the cafetorium or something like that. I mean, it's like a gymnasium, theater, eating, everything environment. But one of the things I've noticed is they're doing centralized testing. And so now they're bringing hundreds of kids on folding tables with laptops or tablets into that one space. So they can watch them take standardized testing. And I get administrators calling me saying, we're having trouble with our testing. I'm like, you have one access point that's a 4x4 AP, and you got 400 kids in this room trying to use their devices. Of course you're going to have problems, right?
So, now it's my turn, John. I have a question about that, because it is something that, you alluded to even before we started recording this episode, about, online test taking. And, and then you were talking about the reliance of education these days on the internet and networking and technology and Wi-Fi specifically, because, with the exception of the computer lab, you're not going to wire every student in. And I'm always curious about when you get these calls about the online test taking, where they put everybody in we call it a multi-purpose room, where they have the collapsible, the foldable tables and chairs and everything like that. How would you solve something like that? I mean, is it like, do you bring in like some APs on a stick and, be like, hey, we're going to turn off APs around that area? I mean, is there I mean, to me, I look at it as like almost like an event and go, you know what, we're changing how we're doing our day-to-day business and we're making an event. And so for me, I'm like, well, a no-brainer is you have this plan where you say, hey, we're going to bring in APs on a stick and we're going to set these things up. I mean, is that something that
I've
is
seen that
happening
strategy.
or should happen?
We've done that, right? So I've seen people do that, and a lot of times at the get-go, when I'm doing an RF design for a school district, I'll ask them, "How are you using this large space?" Right off the bat, you tell me what's the maximum number you plan to have connected in this space at any given time, and that's per classroom, per community space, per in this case. Uh, the in the event space, the cafeteria. So there's a couple of strategies, right? Yes, I typically will say, first of all, you need to move past a standard 4x4 access point, multi-user MIMO. Let's move to the top of the line high density access point that's got 8 streams up and down, right? Let's go to something that can handle, many more concurrent devices, has more horsepower, has more bandwidth, is backfed with multi-gig Ethernet, has appropriate power. And let's then figure out how many of those we need to put in this space in order to handle the maximum load. Now, a lot of times in these environments, I don't necessarily always put the APs in the room. So there may be 1 or 2 in the room, but typically there's some circulation spaces right adjacent to that room, maybe a hallway or corridor, some other classrooms or things like that. What I try to do is I'll use the walls around that building, around that space, to attenuate some of the signal. I have APs just outside the space that are kind of reaching in and grabbing a corner of that space. It helps, again, limit the power and the throw and the co-channel interference while still providing that additional level of connectivity, right? So strategically placing them is really key, right?
And you warm my heart because I thought I was the only person that would look at attenuation and look at some of these, because I used to get this at my last job where there'd be like, how do you deal with these walls, that give you, like this crazy attenuation? Like, normally we think of a sheetrock walls like 3 dB. And yet at my previous location, my previous job, we'd have walls we had some that were 30 dB. And they'd be like, how do you deal with that? And I'm like, how do I deal with it? I'm like, I use it. I use this attenuation for my benefit.
Yes, exactly.
So I think you bring up a really good point that I think a lot of people, and especially in K through 12, don't necessarily think about because they're not as learned in the black arts of Wi-Fi and radio stuff, that sometimes embrace these high attenuation things, like, oh, we have this one wall that's crazy. Well, that's great, because use that to your advantage. Don't look at it as an impediment. Look at it as a benefit. It's a benefit. And so I love the fact that you brought that up because not too many people think like that.
Yeah, it's and there's other structures, right? So a lot of times there may be support beams or other things in a facility that you can use to create that radio isolation that you're looking for, so that as you rotate through the channels that are available, you're not re-engaging on the same channel with another AP, because you've used the facility to help control that spread.
So that brings up a good point, and I swear it's not like we're watching a script, but you're mentioning channels, and you probably are reading the script. But anyways, it's good. Yeah. That's good. That's why Jim writes it. So you mentioned channels, and and Jim, I'm going to tie them together because Jim, you mentioned the black arts, and we had this conversation I think yesterday about a friend of yours. One of the problems, and this isn't on the script, so I'm going to screw everybody up a little bit. One of the problems with a lot of, and I've seen it just in talking with some folks in higher ed, or just ed, not higher ed necessarily, just educational support folks in general, the training funds. Well, the timing to do the training and the training funds. So a lot of these folks are winging it. They're not necessarily CWNEs like Jim and I. They're not necessarily RCWA or any sort of level of training. It's literally on the job, seat of the pants, and getting it done and, MacGyvering it, which is great. And my hat's off to you because we were all there at one point, believe it or not. so they don't necessarily know a lot of the tricks. But so you mentioned channels, and channels are a big deal. Channel width is one thing we can get into, but DFS channels is a hot topic. So, would you recommend using it? How do you steer the people in that direction? Because it's hard to know, right? Like those channels, some devices support them, some devices don't. Jim's shaking his head because I know what he wants to drop in there.
This is so in the RF engineering space, this is a bit of a religious debate in my mind, right? So the idea, I am pro DFS channel, right? So I want as much channel diversity as I can get in a space. And so my advice to most of the schools that I've worked with, and it's been sound and it's tested and it's worked out, is turn them on. Okay, let's get them on there and make that diversity of channels available in that 5 gig space, and then watch your log for a while and see if you get what I would call a DFS event, where a radar, NextRad sweep comes through and your APs, ungracefully vacate the DFS channel and drop everybody like a rock. And then they struggle to find their way to, it's not announcing that it's changing. It just happens, right? So watch the log, see if it happens. If it's not happening, then stay with the DFS channels, right? The caveat being that, I've run into devices that do not support DFS channels. I remember one particular device that was used for screencasting from a tablet to a projector, and whenever the AP in the area was on DFS, it would drop and it couldn't use it, so they had to eliminate those channels. But for the most part, the benefits have outweighed the risks of using it for most of my school districts. I have one district that's pretty close to an Air Force base that has some problems every now and then, but it's not like a daily occurrence. It's like once a quarter, once a month, they might have an AP or two that'll drop and rechannel. But otherwise, the benefits of being able to use those additional channels provides capacity and throughput and connectivity that's beneficial to performance.
So 100% agree. Go ahead, Jim.
A couple of things I'm going to mention out there for our listeners, and I'll put the links in the show notes, is clients not working on some channels, specific channels, things like that. It's actually a very common thing that we run into in the Wi-Fi world. And there's a couple of things that we use. And so if you're a school administrator sitting here going, or you work in IT and you're like, how do I figure this stuff out? There's a couple of resources that we use that I want to throw out there for everybody. And the first one is a link, and we call it the list, and it's clients.mikealbano.com. And
he recently updated it too.
Yeah, he did. I think he anyway, he's back. But anyway, and I'll put that link in there. And if you go there, there's just these lists and lists and lists of all these different devices, and it tells you what channels they support. And so you can, if you have a school issued device where it's like, hey, all of my students are using this one Chromebook, you can go find it and figure out, hey, does it support DFS channels? Maybe it supports a lot of them. Maybe, I found a device recently that supported all of the 5 gigahertz channels except for 4. And it was really up in the terminal Doppler weather radar channels, the 120, 124, 128 range, kind of 132. It was in that chunk that it didn't support. So that's a great resource. The other thing, and I'll put a link in the show notes, is a tool called the WLAN Pi. Now, the cool thing about the WLAN Pi is it has a tool called Profiler. And what you do is you basically, and this is what is used to build Mike Albano's list, is you take your client device and you associate to this, or you attempt to associate to this tool on the WLAN Pi, and it fails. But what it does is it tells you everything that client supports. And so those are two things. And I've used it in the past when I was having problems, and it come to find out that the brand new device that they bought for all of this one group didn't even support 5 gigahertz. And it was and I'm like, how did you buy a device in the past couple, literally like in the 2020s that doesn't support 5 gigahertz? And they managed to do it. And so then it's like, great, now I have to redesign my network to support 2.4 in places where I really wasn't going to do it. So 2 resources that can help you out with that one.
That's great. I get these calls too, where that people are saying, "Well, I'm only getting 50 meg or 80 meg, and this other device is getting 400 meg or 300 meg, and why is that?" And having taking the time to explain multi-user MIMO, multiple streams, that device is different than this device. This one's on 2.4, that one's on 5 gig. It takes a little while for people to understand that not all devices are equal. I've even seen for example, in the Chromebook space in education, what appears to be a homogeneous run of the same model of Chromebook. Somewhere in the process of the production line, they updated the firmware drivers for the chipset, or there was a change in a chipset. It looks like the same model and everything else, but it's physically different or software different, and as a result the performance is different. And so making sure that the device drivers are up to date on these devices in education, that's a challenge. And understanding when you buy, and they're going through thousands of Chromebooks. When you buy these Chromebooks every couple of years or so, really pay attention to what, they're inexpensive, they're wonderful devices, they're basically almost disposable, but look at what the RF characteristics and the hardware is telling you, right? And I'm with you on the 2.4 thing. I have a couple of warehouse folks, and these barcode scanners and belt-mounted printers, they're all on 2.4 still to this day, right?
It's kind of you mentioned 2.4 and you're talking about 5, and we talked about channels, and you said you're a big fan of using every usable channel you can. So at the end of the day, 2.4 serves a purpose, whether it's IoT or not, right? And it's a hot debate with anybody in Wi-Fi, whether you're a noob or a seasoned veteran. Like, it's the running joke: 2.4 is dead, long live 2.4. At the end of the day, it's still 3 usable channels, and even if it's like the worst performing devices that, like in the case of IoT, not that IoT is bad, but like if it's devices that aren't critical. Let's call it that. Mm-hmm. They can work on that. IoT devices don't need a ton of bandwidth to necessarily work. For me, in past lives, I left that for the guest network. They could do 5, but I left 2.4 on for the guests because I didn't care. They just wanted to get on. But we've got this new gift from the government, 6 gigahertz. Yeah. So while AFC is still not a thing yet, and then maybe it'll eventually will be a thing in the next few months, maybe we'll see, it is usable for the classrooms. So I'm kind of curious how that's playing into designs. I mean, it's a huge chunk of new spectrum that's got to help.
Oh, for sure. I'm super excited about that. I mean, when you lay that down on on a sheet of paper and you look at 2.4 little space, 5 gig big space, 6 gig is the other two combined, and then more, right? And so the diversity of channels that's going to offer is just a phenomenal windfall for us. I think it comes with some interesting opportunities and also some challenges, some things to be cautious about. So far, what I've heard and what I've read and what I've experienced is it attenuates obviously a little faster than 5 gig. Right. And it's kind of that similar thing. 2.4 penetrates wonderfully. 5 gig attenuates a little quicker. The signal drops off. 6 gig a little higher, also, attenuating a little faster. And so revisiting your design and your AP placement, most of the folks, I'm thinking of the RF design tool people that we work with, other things are saying, we don't think you're going to have to redesign this, or, if you're going to drop and swap some APs, it's not going to be an issue. I'm kind of reserving that and saying it depends, right? So it depends on the environment, where the APs are, how you're going to use them, and all of that. But the main thing is we're getting this entire amount of brand new spectrum. The devices will have to support it, so the devices have to catch up. And we've got some caveats around the high power, low power, or standard power versions that we have to deal with, some frequency coordination if you're doing any outdoor. And I have a number of schools that do outdoor bridging, and or they do their football stadiums or their track and field spaces with outdoor APs. And so there'll be some frequency coordination things that happen once we get to that ability to put these up outdoor. But for right now, I think the benefits are phenomenal, having the ability to have all of those channels. I'm
how's
reserving, not so good, right? So I think there's a bit of a wait and see here. What's going to happen with this Wi-Fi 7, that's coming down the pipe for us, and so on we're caught up in E-rate cycles and equipment refresh cycles and chipset manufacturing cycles and many other things that I think are impacting the Wi-Fi 6E, push per se.
Well, the one thing I can tell you about 6 gigahertz, well, I can tell you two things. One, there is a significant difference between, the low power indoor that we have today and standard power, because AFC still isn't here yet, and John has his own personal rant about that we don't have time for. And so that I was really surprised when I saw that difference. When you think, oh, low power indoor, no big deal. But when you actually see it in operation, it's a big deal. The second thing I can tell you is it goes back to your point about the drivers for the chips, right? That is a very big deal at 6 gigahertz. So if it's something that you're looking for, because yes, I could see 6 gigahertz being a great thing for K-12, assuming that your devices will support it. But it's going to also introduce something that's going to cause a lot of pain for administrators, the IT people in these districts, is keeping the chipsets with the correct firmware because it is so new. So those are the two things I can tell you about that.
Yeah, my school administrators, we've been educating them about the need for multi-gig switching as they do switch refreshes, to talk about what their uplinks and stacking bandwidth looks like in anticipation of these high capacity, high throughput APs. So we've been talking about that, and I think the other thing that and we touched on this earlier, I routinely tell my schools, if you have dual band devices, Chromebooks that can do 2.4 and 5 gig, fly the student SSID on 5 gig only. Okay, devices have a propensity to want to connect to 2.4, but a lot of times, we're on 5 gig only right now. I think at some point when we get to Wi-Fi 7 and we're doing, 2, 4, 5, and 6 concurrently, and we're able to, pick those channels that we're operating on, it's going to get really interesting in that space. And so I'm excited about the additional frequency. I think we've got to work through some of the cycles for refresh and other things. And I think, it's going to be a little while before we see a propensity of devices in the school that can support all of that.
And I think you hit on something important that's worth, I'm stealing something that Jim and I talked about from the beginning of the week. It's important for anybody listening to this to remember that maybe, we've got some higher ed or just general education support people listening to try and get a little bit more informed. At the end of the day, Wi-Fi is not a Wi-Fi decision, like where the device is going. It's all the clients. And I'm not blaming the clients. It's the reality is it's a client decision. So our job as Wi-Fi engineers or SEs or, experts, whatever you want to call us, we need to make sure we make the decision as easy as possible, whether we're turning up power. We'll have another conversation in a little bit about that, probably for another episode, but how we can sort of influence devices to go to things like you said, make the SSID that you favor only 5 gigahertz, things like that, because clients will be sticky. Clients will prefer 2.4. Just they make funky decisions that we can't really control. We can try to influence. So that's something important. It's not a cop out when your wireless engineer that's supporting your system says it's a client decision. It's legitimately the truth. I can offer it. I can't. It's the old, I can lead a horse to water. It's not my fault when it drowns. Because I can't control what that horse is going to do when it gets to that Wi-Fi signal. I can't. And with that said, I think this is a good, I'll be behind the curtain here. We're going to split this into 2 episodes. I think this is a good splitting point because most of what we have left to talk about is on my favorite wired network subjects. And Jim's going to laugh because he knows it's, yeah. Anyways, so I don't think I have anything else on wireless. Jim, what are you thinking?
I have lots of stuff on wireless, but
we might have a couple that we start with in round 2, but I think this is a good stopping point for the first part of this one.
Yeah, let's bring Ryan back for a second episode. Let's do it.
We'll do it real quick. But so with that said, we're going to hit the outro music, and if I can find the right button, and we're going to hit it, and then we'll be back in a jiffy. So hang on with us, Mr. McCaigue, and we'll talk to everybody on the next episode.